Hello, I'm Nobby. Welcome to my workshop. This is part 6 of the PM Research engine build, and the part I'm machining now is the connecting rod. Rather a difficult part to set up. To work out how to set this up probably took me a good part of an hour because the ends here are machined to sort of different widths, this part and the part here, and of course if you get this end clamped down, so I've got it down to my fixture plate, this part obviously sits above the surface of the fixture plate, so I had to work out the ideal sort of thickness for a shim to put under here. Luckily I've got a set of feeler gauges that I can take out of their holder, and I've put a feeler gauge underneath this part. So I've done a bit of sort of work out. I've already machined the underside of this and also machined this end, so I've just got one end to machine now, and it literally only needs the tiniest amount. What am I taking off that? I think it is minus 7 thousandths on this end. That end I only need to do this side of the part. That only needed a 3 thousandths off that end. So I'm going to try and get this machined as accurately as possible. I've clamped it down as firmly as I dare because I don't really want to bend the part between these two bosses. What I've also done is use some toe clamps here, pressed against the edge here to stop that moving while I machined it. I experienced that problem when I machined the other side, that this part started to move across this way. Although I was only machining a small amount off, it started to push this round, so I had to stop and get it back into position and put this toe clamp against it to stop it moving. And I've done the same this end. I've got a toe clamp on each side to hopefully stop that part moving. So what I've got to do now is bring the cutter down so that I can touch off, but I'm using the sort of old trick of using a piece of cigarette paper, if I can get in there, underneath the cutter, and then sort of keep moving that while I bring the cutter down. So sort of gently bringing that down until it catches that. Move that from sort of side to side until that catches. That's it. I've got it sort of, it's holding the paper sort of really tight, you can see there. I mean, cigarette paper only measures about 1,000th, but if I sort of grip it quite well, that probably will take up that 1,000th, so we can move that across and the paper will move out of the way. So I can set the Z movement on the DRO and then bring the cutter down the 7 thousandths and move that across. It's not a huge amount I'm machining off, so I'm going to do it all in one go and hope for the best. So if I bring the cutter down, and then we've got that set. I'm locking off the Z movement. Let's make sure I've got the cutter lined up. I'm hoping, I think I'll be okay, but hoping on this side I'm going to miss the tops of these toe clamps, but if it nicks them, it's too bad. So right, let's move that across, and I'll bring the cutter in a little bit closer. I'm sorry I didn't show all the operation here, but this was such a long job to set this up in the first place. So I thought I'd just bring you in for the final part, just to sort of show you what I'm doing. Right, let's start the mill up. And gently wind across. So that's it. Let's get the head of the mill right about the way. So now I've got all the both sides of this machine. So I can take this off and measure that up. So I'm hoping it's going to be okay within a thousandth or half a thousandth, something like that. But while I've got it set up on the faceplate, what I want to do is to drill the required holes in here. In the casting, that there are already some little markings on here already for the distance between these two holes, which is it's a very fractional measurement. It's 1 inch .656. And I have sort of measured across there using my digital gauge, and it is that measurement. So that's pretty accurate. I imagine if it was a fraction of that out, it probably wouldn't make a great deal of difference, really, because this will join to the crosshead, which also then joins on to the piston rod shaft, as the piston rod. But there is some adjustment there, so a small adjustment can be made to that afterwards. So I'm going to use these positions, probably set it up using a little pointer in here to get that lined up in the centre here and here, and then drill them out. This end is quite a tiny hole. It's a number 43 drill, and this end is a 3/16 reamed hole. I've looked through. I've got a box of reamers that I bought a few months ago. I was in a sort of not a junk shop. It was like a curio place, and I spotted an old cigar box. And I often buy cigar boxes because the little wooden cigar boxes are so useful to store bits and pieces in for the workshop. But when I opened it, there was a load of reamers inside it. They were all imperial sizes, the ones where you could actually read what the size is. And during the build of this model, I've so far already found 2 reamers exactly the size that I need out of those, and luckily there was a 3/16 reamer as well, that I can drill and ream this hole out. So I've now got to get sort of set up to do that. Setting this up to drill these holes sort of perfectly perpendicular, I know is going to be sort of a very difficult thing to do. So as I've got this mounted on my my little sort of setup plate here, I'm actually going to drill these through into the surface here. It's going to make obviously holes in between where all the threaded holes are, but I guess that's what having a fixture plate is all about. So I'm going to drill sort of right the way through here. This will need drilling 11/64ths, which I hope I've got a drill that size. And this one obviously is going to make a tiny hole. It's only a number 43 drill, which is tiny really, but if it makes sort of holes in the surface, in the fixture plate, for me that's not going to matter. So that's going to be the next job. Drill these holes before it's removed, so that part then is all done. I'll show you the part when it comes off the fixture plate, because I've gone all around the edges here and around here, gently filing it, and along the sort of long edges here. The rest of it I don't want to touch because I want to keep some of the shape that this has produced where it's been cast. Obviously some surfaces have got to be machined nice and flat, but I don't really want to overdo it. Just wanted to sort of clean it up a bit. The thing is that when this was cast, the two halves of the sand casting part were not aligned really well, and then you had on the edges here you had a bit of an overlap on one side, so I've tried to sort of file that round to make it look reasonably round, but I don't want to overdo it. You know, that's is for me is going to be good enough. But anyway, I'll stop for a moment and I'll get set up so I can drill out these two holes here. Well, I'm set up now to drill the holes. So this is the first one. This is the one that needs a number 43 drill, which is quite tiny. There are within this kit, I had to go through all the drawings to see what I needed in the way of drills. Obviously I didn't do that carefully enough to see what I needed in the way of reamers, but so far I've been very lucky. I recently visited the Midlands Model Engineering exhibition, and I managed to pick up the 3 number drills that I need for this kit. I didn't want to buy a complete set of them because I think this is the first time I've ever used number drills, so I didn't really want to invest in a huge set of them. I think obviously there's 60 in a set. But it's quite inexpensive just to buy individual ones, so in the future whatever I need I'll just buy them as required. So anyway, I've set up the pointer into position there, and we'll drill this one first. Hopefully it will all go okay. Let's just take the little pointer out. I'll find the hole in the chuck. Here we are, there you go. So we'll take that out. I'm sort of going to rely on these little pot marks in here that they will guide the drill through nicely. Hope they do. I'll attempt to put this drill in here. Let's hope all goes well. Okay, bring that down. That's it. I can see some aluminium coming up through the hole, so I know I've gone all the way through. I've kept the feeler gauge underneath, and of course this has just come off a set of feeler gauges. There is a hole at one end, so I rearranged this to get the hole underneath that so that it would not try and machine, because I imagine this is quite hard steel. I didn't want to machine through that as well. So I think I'll leave that in there just for... no, actually I need to put the pointer in actually. Let's take that out. So what I'm going to do is move the the little pointer across that measurement that I mentioned. So if I zero out the X, drawing again, and then I can move that across the 1 inch 656, and that should bring me sort of near to this hole here. Let's see how well it works out. 1 inch 656. Five. 656. Right. 1.656. 1.656. Right. Okay. So if I bring the pointer down, it's not going to bring me exactly over the hole here. I've got to move the little pointer across slightly. If I use my magnifier to line that up, that should put me right in the centre of that hole, hopefully. It does, yeah. So I think what I'll do first is drill a slightly smaller hole through here first. Luckily I've got a few imperial drills, so I've got a little set of them that goes up to 1/4 inch, but luckily among some of the other ones that I have got an 11/64 drill, which is the correct size for the reamer. 11/64 for the 3/16 reamer, so hopefully that will do the job. What I'll do is I'll find a drill a little bit smaller than this and drill through this first to give this drill the best chance of drilling the hole nicely. So bear with me just a moment. Apologies here. I think in the last part of the video you saw me drilling this hole at that end, and I'd got it all set up and moved the X movement along to give me the right distance to this hole. But when I reviewed that bit of footage, I realised that I don't know what happened. The camera cut out, and I didn't record drilling and reaming this hole. I'm very, very sorry for that. I can't do it again. But anyway, it did work out okay. I used a little pointer in it to move along here the measurement, which was 1 inch and 656 thousandths, and got it aligned up with a little pot mark in this end. Drilled it with an 1/8 inch drill, and then drilled it with the 11/64 drill, and then reamed the hole. I mean, I luckily found that I had this reamer. I'm pleased that I had it. So that worked okay. I know this is a hand ream, but it sort of worked okay. I have problems with I mentioned that earlier. I don't know that the milling machine doesn't like running very slowly. I have problems with the milling machine all the time with this if I try to ream on it, and I probably know that I'd ream that at too high a speed anyway, but there's nothing I can do about that. But anyway, it's worked out okay, and I've taken, as you see, I've taken the part off here. When I drilled that hole, I managed to arrange things so that I'd got the feeler gauge under here. They've all got a hole in here which holds them into the little feeler gauge set, so I got that underneath the hole, so I didn't try and drill through that material. Then the other thing, just to show, is that I did go round just cleaning up the sort of rough edge here and here with a file, and filed around here to make that look a little bit rounder than it was, because there was quite a bad overlap in the casting, obviously where the two halves of the casting weren't sort of lined up particularly well, but I've machined that, I've sort of filed that round to make it look a bit nicer. I'll probably go around that again with a bit of emery paper just to sort of clean it up, but I think it looks okay. And I've also filed these sides and across here, and that's as far as I'm going with it. I'm not going to do any more filing on this. I know that some people would file all this down and polish it up. I don't want to do that, because although this has got a sort of a rough surface to it, I think that looks quite nice actually, so I want to leave it as it is. This can be mounted in position, obviously that way up or that way up, doesn't matter. So when I come to assemble everything, I can put this in which looks the nicest side up. I think that side probably will look the nicest to be at the top. So right, so that bit's finished. The next part I've got to make is there's a little bushing required to go in here, because this end, the big end, fits onto the cam. So there's a little screw bolt rather goes through here and screws into the cam, and to hold that centralised, there's a little bushing goes in here. So I've machined this part first, because then I can use this bit to machine the bushing to size. That, I think, on the bushing is the only critical measurement required. So that will the bushing will go off. I think it goes on this side, that will go over it, and then there's a little washer on this side with the little bolt that goes through that. So that little bushing will be the next part that I'm going to machine. So there we are. I'll obviously bring you back for the next part. I'm very, very sorry that I didn't notice that the camera had switched off. I don't really know why it did that, but anyway, it did. So forgive me that I couldn't show you machining, drilling that end as well, but there we are. Accidents happen. But anyway, bring you back for another part, and keep a better eye on the camera this time. The part I'm making next is the crank bearing. The material they supply in the kit is 5/8 steel. I don't know what grade it is, but I've made the eccentric with this, and it did machine very, very well indeed. I've got to turn this part down to 5/16. The overall length of the part is 0.2538, and there'll be a section here which is going to be machined down to 0.187. So I'm going for the larger diameter first. I'm giving my diamond tool an outing today. I would have liked to have been able to have bought one of the diamond tools from the Australian company that are making these, but quite frankly it was a very expensive item, and I couldn't really justify the cost. So I made my own. I made this set actually a few years ago, because when I was visiting the Model Engineering exhibition in London, the society there, SMEE, one of the guys there working on a lathe had one of these that he'd made himself, and he showed it to me and explained how he'd made it. So I made some notes. I think I took a photograph of his one as well, and he's quite happy to share that information with me. So when I got back, the sort of next project was to make one. I actually made the body out of aluminium because I wasn't quite sure how this would turn out, and rather than sort of make it out of steel, I thought I'll make the body out of aluminium. So it's rather a sort of crude looking thing, but it has all the correct angles set up. And the nice thing about using this tool is that the actual cutting tool itself only needs to be ground at one angle only. That gives you the clearance in all the directions you need, basically. And it's producing a sort of a reasonable surface here as well. So although I'll sort of carry on and use this for a bit and just see how I get on with it. So I'm going to machine just a bit of this. I won't machine the whole thing on camera because there's quite a bit to come off. It's sort of about half the diameter of this has got to come off. So just make a couple of cuts and then I can bring you back when I'm near to size, and then start machining the other part of this. It gives you a dimension to cut here, but it's got to be machined so that this part will fit over it. So I can use this part, the actual crank, as the gauge to make sure I machine that the right size, so it's a sort of a nice fit. Doesn't need to be a tight fit, just a sort of a nice sliding fit, because this part obviously this part will sort of rotate inside here. Okay, I'll carry on with this and then I'll bring you back when I'm near to size. Right, well, I reckon it's 8/1000 still to come off. I don't think that the measurement here is got to be that precise, because the part here will be machined down to take the crank itself. The part at the back really is only sort of like a shoulder. Obviously I like to get the measurements as close as I can to the plans, but if this was a fraction here, it's not really going to make a great deal of difference, really. It's just the shoulder for the crank to come up against. But anyway, let's get that down to size. Well, I think that's good enough. So now I've just got to set it up to machine the length out here, just sort of mark that up. Or I'll put some bluing on here, and I've marked the actual depth of this part. So we machine back to that now. Okay, I'll bring you back when I'm down to size. Well, we're on size, so that's a nice fit on there, and it's nice sort of free movement. Also, the end here just needs to come just slightly outside the edge here, so that I can just feel that edge there with my fingernail, because when this is mounted, what I've got to do is drill a 1/8 clearance hole through here as well, and it will be parted off at the back here. And when this is set up, the crank will go on here, and then there'll be a little washer on the outside here, and then the bolt holds all of that in position. So that needs to be, I reckon, a sort of a nice fit, but a loose fit, so that it's going to move freely, basically. So that's basically done. So I'm just going to take the sharp edges off that, and then set up to drill the 1/8 inch hole through here as well. That worked out nice using this tool. I mean, I would normally just have used a carbide tip tool for this, but people keep telling me you're going to get a much better finish using the high-speed steel tool anyway. So they're right, that's given me a very, very nice finish, and I can sort of carry on with the last part, and then that bit's done then. And that's fine. Okay, bring you back for the next bit, drilling the hole. Okay, well, all those features are now machined, so the only job now is to drill a clearance hole through here at 1/8 of an inch. So let's move the tool. That's my version of the eccentric engineering diamond cutting tool. Rather sort of crude looking, but it works. So there we are. Give you a quick look at that. Right, so I set up now. I'll get the centre drill in position, and but we'll start that process now. Right, that's the hole drilled. So now the next job is to part this little piece off. So we'll get set up for the parting off tool now. Okay, we're all set up for parting off now. Got the parting off tool all squared up. Then I've got this little rod inside here, which hopefully will catch the part when it comes off. Then it won't go flying across the workshop. Got the lathe running at a reasonably low speed. So let's see how we get on. There we are. And that's okay, and I've not lost the part either, which is good. Just move the tool out of the way. I've put the part back in the chuck again so I can just clean up the surface there. I think I've got about 1/8,000th that I can take off there just to bring that to size. Okay, that's about right. I'll just take that sharp edge off there. That's it. That little part done. Find the chuck key. I'll take it. Oh, here we are. Take that out. There we are. So that's in focus or not, I don't know. I think it is. So that's the little part. It's sort of coming out of there. So I think that looks quite nice actually. It's come up beautiful. There we are. So that's basically it for this part. I now can move on to something else now. Before anyone tells me off, I know, if you've probably spotted, I've got long sleeves on. It's absolutely freezing cold in the workshop today, but I was determined to get out here and finish this little section off. So don't be too hard on me. I don't do cold. So there we are. So that's it. So thanks for joining me in the workshop again, and let's come back with the next part of building the PM Research engine. Thanks very much indeed. Bye for now.